Hi, Paul. How are you? Can you hear me?
Oh, yes, I can, Art. Hey, thanks
Hi.
for doing this session with us.
Oh, absolutely. Thank you for the invitation. It was
Yeah, I
great.
I just jumped on here from the first enforcement session with the lithium battery fire thing. So,
Were you the one who delivered the subject or
no,
the
I was just
presentation?
being. I'm just a moderator today.
You are, okay.
But we had one of our members was doing the presentation along with a local a fire chief here in Illinois.
Mhm.
They had a big lithium battery fire in the summer that they
Yeah,
were dealing with.
I wanted to attend that.
Okay.
Unfortunately, is it coming up here shortly or is it on right now? I think it's on right now, is it not?
We just got done with that session, but it all got
Okay.
recorded.
I did. Okay.
It did.
I'd
Yep.
like to see that. Yeah.
Yep. That was a
It's
first enforcement session. This one's a second.
okay.
So, yep.
I've had some complications today
Yeah.
with some other competing priorities, so my
Okay.
apologies, but hope
Sure.
I will see it definitely.
Sure. Well, thank you.
So, yeah.
What can I
So
do to assist you?
I think I'm all set. I
Okay.
mean, looks that way from this end. What do you think? I mean, you could see the presentation, right?
Yeah, I can
Let
see
me
that. We got some people chiming in here, it looks like.
let me see if I can
So,
play this video. Do you see this video here? Take a minute to
yeah,
load.
I see it.
Right there. Can you
Yep,
see
I
it
got
playing?
it. Yeah, I
Okay,
see it.
great. All right.
We got about maybe 7 people in here right now. I wouldn't mind maybe waiting to see if anybody else chimes in
All right.
here, maybe. So, and if not, we'll give it a few minutes, then we'll go ahead and start, I would
Yeah,
imagine. So,
we're still early, right? I mean, 12:53. We got 7 minutes.
yeah,
So
I think you're right. So, yeah.
yeah,
Pete wanted me to chime in early here just to kind of hang out in the room here.
sure.
So, the virtual room. Yeah. So,
I'm gonna add some polls here while I got a minute. Um,
I was just sending an email to Pete there. So,
yeah,
uh, so have you been active in Illinois since you were up at Orchard Hills last year or 2 years ago?
yeah, we've done some other work there. I can't share with you the other sites we're working at because they're investor owned. I can't mention Orchard Hills, but
Okay.
you obviously know that.
Yeah.
But we are, and we're trying to frankly grow the business in Illinois. We
Mm-hmm.
do a lot of work from Minnesota down to Kansas and everything in between that and Michigan. We
Okay.
have technicians now also doing quarterly monitoring as well. So we have a field operations group.
Mm-hmm.
So yeah, it's been good to us, the state.
Right. Do you do other industrial sites besides landfills too?
We have not at this point in time. What do you have in mind?
Oh, nothing. I was just curious. I was just
Okay.
how expansive your business is as far as monitoring and stuff. So,
Yeah. No, we're pretty much focused on the solid waste industry at this
okay.
point in time. But
Okay.
we're going to be in the oil and gas industry in 2020.
Sure.
So we have a lot of capabilities that could put us in other industries.
Right. Yeah, it seems like you do. So, yeah, seeing it in action those couple days was kind of neat. So,
Yeah.
yeah. And where are you coming from now? Michigan?
Michigan. Yes,
Okay.
sir.
Okay.
Yeah.
Very well.
Um, and where are you out of, Paul?
We're in north central Illinois, just south of Rockford.
Okay.
Yep.
And your role in the industry? I'm trying to recall. I know we talked a while back.
Yeah.
You're on the regulator side, if I recall, right?
Right. Yeah, I work for the county office here, and we
That's right.
represent the Illinois EPA here in our county. We have a governmental agreement with them.
Mm-hmm.
So we'll do the inspections for landfills and open dump sites here in our county for the EPA.
Okay.
So,
and what type of inspections are you doing?
It falls under the Bureau of Land for the EPA. Mm-hmm. So it's making sure that the land regulations are followed by the landfills and things. And then, of course, on the open dumping side, as far as waste being managed the proper way.
Okay.
So,
we've been doing some work for other states where they've asked us to benchmark emissions over closed sites that they have in the state. Mm-hmm. If there's any opportunities there, let me know within the state of Illinois.
There are several closed sites for sure.
Yeah.
Yep.
Yeah,
mm-hmm.
Sure.
Yeah, we have one at least. So
I'm sure you do.
Yeah. We got some more people joining in now, so
sure, we can go live anytime.
Okay.
I'll just wait for 1 o'clock or 12 o'clock your time.
Right.
I thought this was at 1 o'clock, and on Hopin it shows it as 1 o'clock. I didn't know if that was central or if that was my time.
Yeah, no, I think we're going to be starting here pretty soon. We're rolling right into yours after that first session.
So we're ahead then, it sounds like, because originally I think I was scheduled for an hour from now.
For an hour from now, okay. I can check with Pete on that. I'm not totally sure, but
yeah, I'm looking at it right now. So here you go. I'll just put it up here on the screen. You can see it. So right here, emissions monitoring 1 to 2.
1 to 2, yeah. Maybe that's your time.
Well, that's what I was trying to figure out.
Right.
It doesn't say if it's
it doesn't say, right,
Central or Eastern. So I was confused. I was glad that Pete had asked me to jump on.
Yeah.
But I'm ready.
Sounds good. We can go ahead and start then.
All right.
Thank you for doing this presentation for our group, Art, and I'll let you go ahead and take it from there and introduce yourself and your company.
Okay. Thank you very much, Paul. And thank you to the organization here for allowing me to present to you today. I've had the opportunity to attend some of the other sessions, and I'm reminded that there's a lot of forces, external forces and pressures on this industry, everything from recycling to plastics to PFAS to so many other subject matters. I'm sensitive to the fact that operations are very challenged in terms of all these externalities hitting the industry today. I want to talk to you about another one, and that is about emissions, and more specifically about methane emissions. And I want to share with you and talk to you about the journey that the industry is on relative to emissions. And I want to share with you where we see the industry today and where we see it head in the future, and how our company can provide the ability to have you be prepared for what's undoubtedly coming to this industry. So my name is Art Moore, I should say, and I am the founder and CEO of Sniffer Robotics. I have over 10 years experience in the landfill industry. I have worked in a number of different roles, have seen a number of landfills throughout the United States. Our company does work currently in the state of Illinois, and I'll talk about that here in a little bit. But let's talk about emission monitoring. The primary method used to identify methane emissions over a landfill is referred to as surface emission monitoring. And those who here in the session today, I'd like to just ask you all a question if I can do that here. And there's a poll here. Let me just push this all to everybody. I'd like to know how many people are directly involved in landfill operations. And Paul, if I look at it now on the polls, I don't know if everybody can see that. Or
I can see the poll, yeah.
Okay, so if everybody can please answer that poll, I'd like to get a brief, it would help me sharpen my message here to everybody. So anyways, I want to talk about surface emission monitoring. And this is where those who are involved in operations in one form or another are familiar with the fact that we have technicians walking landfills at least quarterly to with a handheld detector, monitoring or measuring methane emissions over the cover of a landfill. And this is generally done on NSPS sites, and those are in non-active areas, and in areas that are not under construction, as an example. Being up here, I'm in Michigan, not far from Illinois, of course. We have similar weather conditions. This is done year-round. There are numerous hazards associated with this job. You talk to any technician and any company that is actually doing this type of work, to tell you it's highly laborious. It is tough to get people to do the work. It is inefficient because, generally speaking, some technicians will walk a landfill and they'll end up, identifying a small number of leaks during the operation. So it's very inefficient in that regard. They are exposed to other hazards, whether it is slip, trip, and fall, or animals, insects, whatever it might be throughout the year. We do work down south. We don't have to worry about alligators up here in Illinois, but that's a real challenge when people are on these sites in many cases. We were working in Georgia, and we had a technician exposed to black widow spiders, a nest of them. These are just real situations. Up here more in Illinois, Great Lakes region, the biggest issue are ticks. We have our technicians walking these landfills and regularly doing tick searches as soon as they come off the landfill, as an example. These are obvious risks. So the job is also physically demanding, and it is highly subjective. You have people walking past. They try to maintain a 30-meter spacing as they're doing it. That doesn't give full emissions coverage over that landfill. The results vary not only by technician, but every time they do it, they can get different results. We have a site that we have manual technicians walk, and 350 acres, and we monitor how much time they take on the landfill cover system, how many miles they're walking. 57 miles of walking our technicians do on that site as they monitor this site. It's a very inefficient, very ineffective, and subjective method. And I think here, seeing that I only have 3 votes on the role in the industry, and I think we have, about 14 visitors, so not everybody has responded to it.
Right.
So far, it's only regulators at this point in time have responded. So
I think we got 3 regulators and 3 others. We got 6 people that voted so far. So
okay, all right.
Yeah.
So I'll just continue then. So the current we 4 years ago when we started this business, we looked at we believe that there is value in the regulation. We saw value in the regulation in terms of being able to monitor the emission that is coming from the landfill. We also saw value in the fact that we have people on the landfill. In essence, eyes are still on the landfill. close up to the landfill. You can be much more prescriptive in that manner, and especially in terms of the regulations where we have to report cover integrity, and that's something that you really need to maintain eyes on the landfill as you do it. But when we looked at the ability to create or improve this method, we first of all stayed focused on sampling the emission, not the plume. And that's very important. I'm going to talk about that here in a little bit as well. But we are measuring at parts per million right at the ground level, mimicking somebody who is walking a landfill. We also want to localize the source, and that's also very important. So that way we can give fast feedback as to where the biggest issues are, and these can be subsequently remediated. Our objectives in trying to improve this operation are, number one, we wanted to improve the safety of the operation. Number two, we wanted to improve the efficiency of the operation. And number three, and perhaps most importantly, especially when you talk about the future of this effort to better address methane emissions, we wanted to improve the effectiveness of the operation by also using data that provide greater insights to drive action. So I want to share with everybody a quick video of the sniffer drone, which we developed. That's what it's called. It looks simple in terms of its implementation. We have a drone that is flying over the landfill. We have a hose that is attached to an onboard detector. We are pumping up air samples from the ground to a detector that is on board. We're able to measure the methane concentration levels as the drone is flying, and then we are able to localize those back to the specific location on landfill where we have seen or where we measured elevated methane. We have the ability with a 4K viewer, and I'm going to show that, or video. We have the ability to monitor cover integrity during the operation. We have the ability to present this data and map it to give rich visual data to the site owners and those involved, to give them a great deal of certainty and credibility behind the operation. Currently, our technology is being used and very effectively to help identify odor sources, recognizing that we only monitor for methane, but because we identify more sources, people are using our technology, or more leaks, I should say, people are using our technology for the purpose of identifying more leak locations, and subsequently, if they address those, they are effectively reducing the odors. Customers are also using it to verify current emissions monitoring effectiveness. In other words, to benchmark the quarterly surveys that are provided to the regulators. Customers are using our technology to prepare for increased emissions scrutiny. They are using our technology to identify emissions for new designs relative to the gas collection systems. And they are also using it to verify gas collection system effectiveness.
Hey, Art.
Yes.
We have a question from Walter as far as, do you have capability to also monitor for H2S or just the methane?
It's just the methane. Again, we have seen at sites where H2S has been a problem. And we've been brought on site recognizing that we can still, that leak, if it more than likely it's going to have methane, we can identify those leak sources and then subsequently address the H2S. And we can do post secondary operations on H2S after we identify leak sources.
So if the methane is detected, we can probably make the assumption that the H2S and the odor causing components are in there too.
That's correct. In one form or another, we could also have other detectors after we identify the leak source, measure for H2S at those locations.
Sure.
Okay. So, it's really there's a lot of, details here relative to the sniffer drone. I don't need to go through all of it. But I will tell you, it's a patented solution. We just were notified by the U.S. Patent Office that our first application has been allowed. We have some unique attributes of this drone. We have an onboard laser that we are using to keep the drone flying along the contours of the landfill at all times. And that allows us to keep the hose and the air collection system down on the ground at all times during the use of the landfill. That is not driven by the pilot. That is all autonomous from the drone through the system that we developed on the drone. We have breakaway tail very often, very infrequently, I want to say. The hose will get snagged. We've flown on over 15,000 acres now of landfills in about 16 different states. And, I'll tell you, we probably get a snag 2 or 3 times a year. But it's, we do have to, we've developed that system so that way we don't bring down the drone. But in reality, it's a very effective and efficient system. And, we have operating conditions. Basically, we say that if an operator's technician's walking in it, we can fly it. This is some videos of, it shares with you the type of work that we have done and where we've done it. We can work in deep vegetation. We have weighted nozzles based upon that vegetation as well that we can use differently to keep it within that vegetation or closer to the ground. We can work in snow and ice conditions. We can work over geomembrane type covers. We can also work in active areas. We can just do, we have a lot of opportunities and capabilities here with this tool. From a pilot view perspective, even though the drone is flying autonomously, the pilot is in fact watching what the work that the drone is doing and where it's at. He or she has the ability to deviate from the pre-programmed flight path based upon, cover integrity issues, or he can mark those locations, come back and do secondary operations. But as you can see, this pilot is there just to watch the flight and make certain it's, there aren't any hazardous conditions that he or she needs to avoid. The other thing that we also do for cover integrity is that we can fly using other sensors, and we can create multispectral imagery where we can look at and give specific counts of vegetation on the cover, identify those areas that are dying or diseased vegetation or, healthy areas as well. During as the sniffer drone is flying, we can actually watch it fly. And this video will show you a path with an exceedance that was noted and recorded. We log all these locations, and then we push those to a mobile app that we'll talk about here a little bit more in a bit. It's called Sniffer Field Ops, where we are providing to technicians or site owners details as to where those leak locations are at. So the one thing that's very unique about the sniffer drone is that we have a very high accurate leak location ability. We have about greater than 90% probability that when the sniffer drone reports a leak of over 500 ppm, that we can manually verify that of over 500 ppm. We record all the leaks 200 and above, actually. And we know that if we, from the sniffer drone, identify a leak source that is measured at 200 to 499 ppm, there's a 50% probability that that leak will be over 500 ppm when manually inspected. It's very important because one thing to know about the drone does not stop. The drone keeps moving. So the detector does not reach a full peak value because it's not instantaneous. So it will, we know that at 200 ppm to 499 ppm, we have a 50% probability that when manually inspected, it's over 500 ppm. And we know that if the drone measures 500 ppm, it's over 90% upon manual inspection that it's over 500 ppm. We've done a lot of work in manual verification of the field, so we have a lot of statistics and data behind that. the other thing we know is that we have a 95% confidence interval that leak will be found within 44 feet of where it's reported by the sniffer drone. And that's the reason why you see these rings. You see an outer ring and you see an inner ring. The inner ring is, on average, that leak will be found within 25 feet. So you can see here that we have a green line. This is the pre-programmed flight of the drone. And you can see, and I don't know why this shows up as dots here, but this was the actual flight path of the drone as compared to the pre-programmed flight. We also have the ability for quality assurance to make certain that we have coverage specifically not to exceed 30 meters, if so desired. And you can see that here as an example. We were over 30 meters gap between the flight paths. Now, our standard protocol is to fly to a 30-meter spacing, but we do have customers that ask us to do 15-meter spacing. We have a lot of capability to do basically anything that a customer would like in terms of the flight paths. But generally speaking, we fly either a 30-meter flight pass or we fly a 15-meter flight pass. Paul, do me a favor. I can't see the chat box, but do stop me if anybody has any questions, okay? Otherwise, I'll just keep on going. All right.
I am monitoring that.
Okay.
Yep.
Thank you.
Mm-hmm.
So we've done a lot of work and through a number of states, as I mentioned, and I'm going to share with you some examples of that work and feedback from customers. We've also shown our technology to the US EPA, and we have a lot of positive comments from the US EPA. So the people who have used our technology generally have been very impressed, and they've always had us come back for additional work based upon what we've done. But I would like to make a comment on a word on compliance. The US EPA has not authorized the use of the sniffer drone for compliance purposes. That's allowed our customers to use our technology for engineering study purposes. And, we are, doing a lot of work in that regard for the reasons I mentioned earlier about baseline emissions, gas collection design, et cetera. We are working with the US EPA, however, to have our process, not necessarily the sniffer drone, but our process approved for compliance. And we can talk more about that here in a little bit. But that is active, and we are hoping that we will be approved here in the near future. So, recognizing that surface emission monitoring is an imprecise and subjective and imperfect method that the industry uses to identify methane, there's a much larger push here now upon the industry, another external force, about being more accountable for methane emissions. There is widespread and general acceptance today in the scientific community that methane is quite problematic to our environment. Not to get into the debate of that, I know that there might be some different opinions here. The fact of the matter is that the industry, as well as the world, seems to be moving in this direction. So, when you take a look at the costs to the industry, I shouldn't say the direct costs, but the exposure to the industry, and I'll talk about that a little bit more here in a bit. That's about $6.9 billion at a minimum right now. That is showing up as an exposure to the industry. Municipal solid waste landfills account, according to the US EPA, are the third largest emitter of methane emissions here in the United States. So it's a big issue. It's that big elephant right now in the room that everybody's trying to get in front of and to try to be ready for this movement that's coming. So these landfills, all these landfills in the United States and elsewhere for that matter, are undergoing greater scrutiny on their emissions. You'll see that in 2030, the US and the EU have pledged to slash emissions. I think it's by a total of 30%. Not only are we seeing this from a policy standpoint, this pressure for reduction or for accountability of methane emissions and reduction in them, but that's being fueled by policy. However, there are a lot of new technologies that are more accurately and more effectively identifying these emissions. And this is being done off-site, off the landfill, which is taking the control out of the landfill site owners and operators and managers. And so technology is also a major reason why we're heading in this direction. There's a great deal of more media and public exposure as a result of that. And of course, the regulators here, I'm sure you all agree that, at least we see nationally as well, that you're adopting these technologies and you're making changes in standards, like what you've just done with what the regulator community has enforced relative to the inspection of penetrations, as an example. So speaking to the landfill owners, and if they're here with us today, and this includes municipal landfills as much as it does investor-owned landfills, you want to avoid the list of surprises. You have airplanes now that are flying overhead in the United States. You have satellites with greater resolution abilities being implemented next year. Their focus is to identify quote unquote super emitters of methane. And the first, everybody and probably in this going through this presentation is already aware of the big study that was done here in California. And you can see that there were municipal landfills as well as investor-owned landfills that were identified and put on a list. And there's been a lot written about this. But the thing that I want to mention is that this was done in California, but there's efforts here to look at all the other states now in the United States, and that is coming. So at Waste Expo earlier this year, Worthing Jackman, who's the president and CEO of Waste Connections, was quoted as saying everybody should be profiling their assets in preparation for future emission scrutiny. That's the reality that people are dealing with. And again, whether or not you're an investor-owned landfill or municipal-owned landfill, this is serious stuff, and it's getting to be more prevalent. And so we've looked at this and tried to identify the needs of the industry, recognizing where this is moving. We believe that the industry needs improved performance for methane leak detection. We believe that the method has to be less hazardous. We also believe that the method needs the ability to quantify methane emissions. I'm going to talk about that here a little bit more. That's different than the actual concentration level, but it determines the flow rate of the emissions off the cover system. You currently have LandGEM, which is a modeling tool in the industry. What we're talking about is the ability to quantify through measurement techniques. We need a means to also better identify odor sources. And that's part of this as well. So you mentioned H2S as an example. That's one that would be an example for this point. The next one is to operationalize the management of emissions. I'll hold that off for a moment. And finally, to provide new tools to help site owners visualize their emissions and improve decision making. So chase is on. There's a lot of activity here going on relative to emissions management, some of what you might be aware of and some maybe you aren't aware of. There's satellite technology, and by the way, that's only improving. You see manned aircraft, you see open path sensors on drones, you see cavity ring down spectroscopy on vehicles, you see tunable diode lasers on drones, you see stationary devices. The industry right now is relying on manual labor. I just don't think that's going to be truly viable in the future. Mm-hmm. We have tried to automate the manual labor aspect, as I mentioned, with the sniffer drone. And we have a differentiated ground up approach. And as you look at the various technologies there, we believe we have a really good approach because we are keeping eyes on the landfill. We are reporting in terms of ppm. If you look at the other technologies like satellites and manned aircraft, they are shooting, and TDL lasers, they are shooting a beam of light at the ground. And that light, they're measuring the methane within that column of light. So they report in terms of ppm per meter. So there's a lot of noise in these systems. They're good first pass systems, but in terms of being able to localize with a high degree of certainty, it's quite challenging.
Sure.
Whereas our technology can localize with a high degree of certainty. And what's also really interesting about our technology is the ability from the data that we're collecting to be able to quantify the emissions. I'll talk about that here in a minute. And I'd like to set that up with this slide because, as I talked before, we want to, the industry needs to, and we want to also be part of it, where we can place a value on these emissions. Unfortunately, nobody's responded as being a site owner or involved in operations, but we have a site that we've been working at where we have been able to quantify and place a value on the emissions off the cover system of their landfill. We're able to take the data, use dispersion models and inverse plume modeling to calculate the emissions, in essence, the flow rate of those emissions off the cover system. What's interesting about it is when you look at our calculations as compared to LandGEM model, they're in the same magnitude. We also have done some other comparable studies, and we find that our numbers are within the realm of measurements for this landfill as well. More studies continue here, but we feel very good about where we're at, and much has been written, and there are many people who are using similar methodologies, calculations to determine gas flux from concentration measurements. Anyways, this site, we were able to determine that there's about $16 million of losses on this site. This is assuming an RNG facility on site and assuming $30 per MMBTU. It's a lot of money. And it doesn't mean that they can directly make that zero. We aren't advocating that here. But what we can say is that as we're flying a site, we can provide to them the gas flux. And what we can also do is we can localize where those largest losses are coming from. And we can all know that, 500, if you get high concentration levels, it doesn't mean you have a high gas flux rate. They don't necessarily go hand in hand. So it adds more data. And this allows sites with a greater degree of certainty look at their investments into the landfill and use this from a return on investment standpoint for making changes to landfill. So it it provides more data with greater transparency to the site owner. So yes.
We had one question that came in regarding some US EPA stuff.
Yep.
The question was from Walter. The US EPA model for estimating methane emissions, is that fatally flawed in some way right now? I don't know if you could speak to that or not.
Well, there's a lot of scientists, a lot of people who are much more can give a much more detailed answer to that. I will tell you that there's quite an effort underway to move from a model-based approach for emissions and gas flux to a measured method, right? And so there's a lot. I think it's a safe statement for me to say that whether it's a landfill owner perspective or a regulator perspective, again, we've had discussions with EPA at various regions, and maybe some here are with us today, that it's understood that modeling is not the most effective method for determining gas flux. Okay. The other risk for the industry is that the measured methods are generally showing that the LandGEM models are lower than what they are in practice.
Mm-hmm. Okay.
All right.
Sure. So there might be a problem with those then.
Yeah, it's another challenge, right? So, if you take a look at the direct loss revenue to the site, and then you also look at the social costs now, and again, there's debate, but just to, put it in perspective, There's a social cost for methane in the previous regime in Washington. It was set at $55 a ton. It was just recently increased to $1,500 a ton, which is what it was set about 8 years ago. And, taking a look at those costs, the social costs are anywhere from $6.9 billion to $355 billion a year in terms of the total amount of methane emissions off the cover of landfill for the industry. It's a big number. So we're working on the ability to quantify emissions and do so and localize those emissions to discrete areas of a landfill. And for the benefits I mentioned, mostly about giving landfill owners the ability to now operationalize these emissions and make business decisions based upon that. So the message I'd like to say here is you don't want to be on the list that I mentioned before of quote unquote super emitters. And there's a way not to get on the list. And, data can be your friend, but actionable information is your best friend. Maintain your quarterly SEMs. Use a semi-annual sniffer drone for scanning your site, benchmarking the quarterly SEMs and identify gaps, quantify emissions by landfill areas and benchmark to land gem, place costs on emissions and operationalize. And we can provide annual reports for that. So, how we go about doing it is we'll fly the site. We'll also we'll collect the methane data. We will also perform cover integrity studies as well. We're on site. We will also manually verify those locations. We can also, if you aren't inspecting your penetration, by the way, we do work currently on non-NSPS sites as well as NSPS sites, but especially for non-NSPS sites who want to double check, where they are from baseline emission standpoint. We also perform very similar activities to what we're doing here. So we have this two-step process. Then we take all the data, we convert it to actionable information. We provide trends and analytics, geospatial mapping analytics. We can provide dynamic viewing and reporting. And we also have this mobile app that I mentioned before called the Sniffer Field Ops, where we take all this data, we push it to a mobile device, so that way operations, they can go and look at these sites or these locations, remediate them, and gain further information. So for those who are currently performing quarterly SEM, we do have a manual group. We work currently in, I think, 7 states. Illinois is one of them. We have technicians out quarterly doing work. And we use our tools, primarily this mobile app that has really become quite a darling in the industry. You can see what our technicians are doing on site when they're there. If they hit an exceedance, you'll get an automated email alert. In some cases, our customers use that because they will go remediate it, try to, while our technicians are on site. We have a very well-trained team. We're very effective. We're very efficient, and we're affordable. So I would encourage you to think about us for manual emissions monitoring as well. We really believe in mapping. We are a partner for ESRI. We believe that mapping and in clear and concise manners informs for action. And we also develop an ESRI. We have developing capabilities internally. We've just developed a wellhead inspection app for a customer. A mobile app that their technicians are using, but we also use it for our own internal purposes. Sure. So I'd like to share with you some examples of where we have done work for sites and customers. One such customer had us on for, I think it was 8 times during a year as an example. As you'll see here, we can take the methane data, we can regionalize it, we can show and explain why the methane emissions are changing over that site, and and in essence, give them a great deal of detail. In this particular case, the site was quite challenged. Had a lot of odor issues. We're proud to say that we were not the reason for their improvements, but we're a part of it because we gave very clear and concise data and information to the site owners that helped them prioritize and help them to basically make their operations more effective. We were also used, or the data was also used for the gas collection system design, temporary covers that were installed on site, a number of other things that were done from the data that we were collecting for this site. We have a site down in Texas that we've been to now, and this is a site. Both of these sites, mind you, that I'm showing here have quarterly SEM going on, and they'll report 3 to 4 hits. Just going back to this previous site, 3 to 4 hits a quarter. I can tell you, we went on site there and we showed them that that really was not there were a lot more leaks than that, which shows the viability of the sniffer drone for identifying leaks. Same case as here in Texas. We have the sniffer drone is much more effective tool for identifying leaks. This is another case where they had odor complaints from neighbors to the north. We showed them a lot more leak sources identified. You can see up here in the northern spot of their landfill major emissions, and from which we're able to isolate and confirm that this was the major odor source. We've been back to that site now. They have successfully remediated that area, and they're really moving on a path to improve their operational efficiency. So this is a site for an investor-owned company. We've been asked to go to a number of their sites. We have been baselining their quarterly SEMs. Again, in this particular case, they do their quarterly SEMs. They get 2 hits. We go in and you can see from the results here that we have a lot more emissions than what has been shown on their quarterly SEMs. This one is one of my favorites. It takes me down the Caribbean. We do some work on the landfills there, and I know there was a session here a short time ago talking about thermal imagery with drones. We have the same capability. I don't know if they talked. I was not able to attend the session, but I intend to watch it when it's available. We use radiometric thermal imagery. We fly at nighttime, and with radiometric thermal imagery flown with the right operating parameters, we're able to localize heat sources, but also provide surface temperatures. And this landfill that we go to has surface fires. They have not been able to do an effective SEM on site because of the 2-to-1 slopes, the hazards relative to the cover system that's there, a whole bunch of other reasons, the vegetation, what have you. We've been able to perform SEMs on site to using our sniffer drone. We've also helped them to identify where the surface temperatures are, or elevated surface temperatures are, and help them to improve the operations there as a result of the data that we are providing them. As I move into the summary here, there are, on the left side, we went through the needs that we identified earlier. I want to talk about our value to the industry. The sniffer drone is becoming and is now the industry's benchmark for leak detection. I think that's shared by not only the majors, but those who use this personally. We can reduce the amount of time on the landfill that a technician will be on the landfill by about 50%, which is good from a hazardous standpoint or safety standpoint. We have the ability to quantify the emissions from the collected data. We have shown that the increased leak identification has been shown to help reduce odors and identify sources. The cost per emission localized by area of the landfill is possible. And that we have developed GIS and reporting tools that aid in customer decision making. So the sniffer drone is the lift in our business. That's what put us on the map, but we've grown to do a lot more than just a sniffer drone. We are a full service provider of drone-based aerial services. Please think about us as well for doing aerial surveying, topographical surveys. We do that in conjunction with our current business. We provide a lot of other aerial imagery, as I discussed, for multispectral thermal imagery. We have customers even want us to fly over the landfills if we're in the area to do videography or photography. We have a field operations group where we can do asset tagging, cover integrity studies. We can do the quarterly SEMs. We also have a lot of data packages around that as well through our GIS services, where we provide mapping, analytics, and reporting. We also develop apps through ESRI and provide back-end support, and we can license their products. So last slide I have for you is this one here. Know your emissions. Know thy emissions. Do that to improve your operations. Do that to prepare or to better meet compliance, and do that to help improve our environment. So thank you very much for the time. The last 15 minutes here, we've left open for questions. So I'd welcome any specific questions if anybody has any.
Sure, thanks. I had one, Art. You had said early in the presentation that you're not measuring the plume. You're measuring right at the surface.
Right.
Which that's how surface scans are done, I realize. But what does you mean by not measuring the plume?
So if we look back at this one slide, Paul, that shows the various technologies that are out there today, you can see that. Sorry, here my mouse is just too fast. Yeah. You have the source, right? And you have, gosh darn it, mouse is too touchy today. Right here, you have the leak source, and you have the emissions, which is the plume. Mm-hmm. So a lot of these technologies here a lot of their noise is in the plume that they're actually measuring.
Oh, okay.
Not able to localize it, right?
Sure.
So that's a broad-based statement, but generally speaking, there's different objectives here, right? There's emissions, which is used to, this is the flow rate, right? Which mm-hmm. the plume is part of. And our focus is really starting at the leak source and then going to measure the plume.
I see.
All right. And the reason being, it's this quote, ultimately it comes down to the accuracy and the speed of finding and flagging the leaks, right?
Mm-hmm. Right.
I mean, you want to it's like capture the flag. You want to get the technology that gets the flag first. And that's our approach.
Right.
We want to get to fixing these leaks.
Right. Because by the time it's in the plume, it's already gone.
It's exactly.
Yeah.
Right. Well, and there will obviously be a plume, right? But we want to start by identifying the leaks first and then calculating the plumes, and instead of vice versa.
Right.
Okay. Just a different perspective and approach.
Sure.
Okay.
I know we still got some people on the presentation. Are there any questions out there for Art? We had a couple from earlier that we tried to address. Okay, right now I have no questions coming in, Art, but I hope that our regulators that were on the call today would keep this in mind for the future and mention it to their sites that they study. I know it was interesting seeing this thing in action up at our landfill up here, or not our landfill, but the one that I go to anyway. And I think it helped them a great deal identify some of the problems that they were having. Because, of course, as regulators, we hear about the odor complaints mainly. And I think this helped to get a hold of some of those odor complaints for sure. So,
well, that's really good feedback. Without explaining who that was, Paul, do you have any other detail you can share in terms of how they use the tool or what information you saw that was beneficial, even to you as a regulator?
Well, I think when I saw the data that they provided from you guys, just the efficiency of locating various areas that had the leaks, similar to your map from before, where the one landfill was getting a certain amount of manual hits, but then when you did the drone study, they had a whole bunch more hits that they weren't aware of.
Mhm.
And then that led them to the landfill that I'm referring to. That led them to change their focus on how to contain those leaks.
I think that's really important. We've seen that with a lot of our customers, right? Where they're chasing one thing and then we go on site and they start chasing other things.
Right.
And we've seen that a lot. I think that this is quite an improvement to the manual process for surface emission management for that purpose, right? The data, really not the data, but the information that comes from it, the outflow of the information is very, very helpful operationally to our customers. They've never seen anything like it before. Never have. So that's good feedback, Paul. Thank you.
You're welcome.
I am available. My contact information might be in my my name here. We do work in the state, and we're also driving through the state to get to other states. We just opened up our first regional office in Madison, Wisconsin.
Okay.
We hope to have others, and including in Illinois in 2020. So I would ask you all if you have any thoughts, questions, you'd like to talk to me more about it, please reach out to me. We're available. Thank you very much for the time.
Thank you, Art, and thanks for the people that were listening in.
Thank you.
Thank you. Have a great day.
You too.
Thank you.